So example 3 is very similar to examples 1 and 2. If you're asked to graph a square root of any function, first of all, you have to have the graph of the function inside. And examples 1, 2, and 3 have always given us that graph. We're going to do another question right after this one where I just give you an equation and you have to graph the inside first. But in these situations, the graph is given. Once you have the graph of the inside function, we're going to use those ideas that we saw in that activity. What are some of those ideas? Well, what square root values don't change? If you square root 0 or you square root 1, and this one you got to be careful because 1 is higher up on the scale, those values don't change. Square root of 0 is 0, square root of 1 is 1. Now there will be times when you do this, and the graph also has some other nice square roots. Like if they had a 4 on there, on the red graph, square root of 4 is 2. That's super easy to do. This one doesn't have that. Okay? Next, wherever your graph, your red graph or your original graph is bigger than 1, when you square root a number bigger than 1, square root of 4 is 2, square root of 9 is 3. Your answer is always less. So we show that on the graph just by drawing the graph. The blue graph is below the red graph. Between 0 and 1, the blue graph is above the red graph. So all you need to show is that your blue graph is above your red graph when the y values are between 0 and 1, and that your blue graph is below your red graph when your y values are bigger than 1. Okay? Some things to be careful of. Again, remember, this would be a mistake. If you went past 1 on your bubble, this would be bad. Or if you went back in time ever, that's bad. Right? We just need to go slightly above, but in going slightly above, we stay between 0 and 1 as well. Normally it's not tempting to go past 1, but in this little bubble part, sometimes you can make your bubble too high. Again, this question asks for domain and range. Your x values here are bigger than or equal to -1. Your range, your y values are bigger than or equal to 0. So in order to practice, what does it look like if they didn't give us the graph? In order to practice that, we're going to add another example. You probably still have space underneath this one. We're going to graph y equals the square root let's do 3. Graph the square root of log base 3 of x plus 1. So you have to first graph the inside. And this is where this is good practice for your test on Friday, because you'll have to graph log graphs on Friday. How do you graph log base 3 of x plus 1? Well, you take the regular log base 3 of x graph and have to move it 1 to the left. What would that look like? Well, if I move my regular log base 3 of x graph 1 to the left, your asymptote would move to x equals -1. If I just think about log base 3 of x, all log graphs have 1, 0. And log base 3 of x, because the base is 3, would have 3, 1. Can you see if you move those 1 to the left, 1, 0 would end up being at 0, 0. And 3, 1, when moved 1 to the left, would be at 2, 1. Shape of a log graph looks like this. So your first job is to graph the inside function. And this is what's different about the first 3 examples we had. They always gave us the inside function, and we just had to do the work. Once you've graphed the inside function, the steps are the same every single time. If you want to graph a square root, you're going to look, are there any values that are 0? Are there any values that are 1? Because square root of 0 is 0, and square root of 1 is 1. Then if it's between 0 and 1, your graph is slightly above. And then after 1, your graph is below. And it's kind of crazy that we were able to graph a square root of log base 3 of x plus 1 by hand fairly accurately, because those are very complicated graphs. If you think grade 11, the most complicated graphs you did were parabolas. We are graphing a lot more complicated stuff now. Okay, questions for practice, you can circle 10 and 12.